can Postgres replace Redis as a cache? This is a good question because one of the strengths of Postgres is that it's very versatile. I mean, many databases, let's say Redis, are specifically made like as a key value store, and Postgres, you have everything. You have a column-based storage. You have the ability to shard. You can have it row-based storage. You have many plugins, right? So it's a very valid question to ask whether we can just take Postgres, because there are many decisions to use that kind of database, and it all adds complexity. And because Postgres is very versatile, free, open source, etc., has many plugins, timescale DB as a time series database, we can do a lot with it. So let's see. Okay, so today I decided to ask people on Twitter whether Postgres can be used. And then there was some comment or some answer. Use Postgres as a message queue with skipped lock instead of Kafka if you only need a message queue. So here someone said that how to use Postgres with some options, and we'll see this repeating because you find with some option, you create your table in a certain way, and then it becomes like a message queue. The whole point is to take Postgres as a database and reduce features. Okay, you have the ability to do locks. We don't need locks in a queue. Here, just do it. Use Postgres with caching instead of Redis with unlogged tables and text as JSON data type. Use stored procedure, or do as I do, use ChatGPT to write them for you, to add and enforce an expiry date. So basically what they're saying here, if you want to cache, do the unlogged, because this would add time. The unlogged is what is the wall, is that the write ahead log, where when you need to do a write, and the database would first write to a write ahead log, such that in any case of crash or something, it could get to a consistent state. So we just keep this. We say this is a cache. I don't care. I just go and want to write to the key value store. And then the cache also has an expiry, and you want most of the data in memory. So I used stored procedures to do this caching and automatic removal. So that's basically it. We just scanned through this article. You can read it. Let's read it. This one as well. Just use Postgres for everything. Okay, so it would reduce complexity, as we said. If you use a single database, yeah, it would reduce complexity. Also, if we'll see this slower, we still need to ask: is 1 millisecond slow for us as a cache? Maybe not. Maybe the whole request takes 100 milliseconds, and 1 millisecond is okay for us. Do we need that much transactions? Is it justifying the addition of another type of databases? In many cases, not. But first, why would I want to replace? Well, this we said it's because unified technology stack. Now we are getting a single technology. We are going to get, and once you are inside the technology, you have your stack predefined, and you just add new technologies to the stack. You become really a 10x. I mean, if you know your technologies and you stick with them, even if they're not the optimal ones, everything becomes 10x. Both almost everything. Things become much faster development, and development sometimes is more critical than whether the database returns you an answer in 1 millisecond or half millisecond. Okay, the cost. What should you expect from a caching service? The primary goal is performance, sub-millisecond, even microsecond, if it's in local cache, but sub-millisecond, I would say, is for cache. Expiration, cached items, because, cache grows. You want to say whatever lives here more than a day, I want to get rid of it. And because it's in memory, you also want to automatically evict the less frequently used. Use it as a key value storage. So how do you turn Postgres into a cache? Basically, first we want a key value table, right? And we want to get rid of things that make it slower. So here they got rid of the write ahead log, what's called wall write ahead log. You just turn it off. Fun fact, Redis offers addition of write ahead log if you want. It's called AOF. So turning the wall, the write ahead logs, improving performance. Wall is designed to force also a disk flash, right? So we want to get rid of it. It's just a cache for this table. Specifically for this table, we tell it don't use write ahead log. It's not global to the database. Also giving up on persistence. So this is like the creation of the table. Let's look at this. Create unlocked table cache. So here's the key to make it not use the wall cache. ID, serial parameter key, and value. The key is text, and the value is JSON. Inserted a timestamp. And they create an index on the key. Now they need to create the expiry of it. So they create a stored procedure, expire rows, if inserted at less than now minus retention period, and delete it, right? And call it every 60 minutes. Yeah, so we are now doing the removal, and in PostgreSql, you need to actually schedule it, right? So you schedule this stored procedure to happen in Postgres. What about the performance? So what is the result? So for the unlocked table, the latency of the read or the write. The latency was 2 milliseconds and the TPS was 485 million. It's a very large TPS. But 2 milliseconds is not that small, right? It's for unlocked table. So this is probably right because they are specifically saying the unlocked table. So 2 milliseconds for writes with 485 million, that's a lot. So I would be interested to see in lower number. For log table, that's double the amount. That is really out of the question, I think, for cache. 2 milliseconds on the boundary. We want this lower. What about the reading performance? So for the reading performance, it was much better. Half a millisecond for read, and I think most of the caches is for reading, right? Eventually. For the logged, it didn't matter. Yeah, because logged or unlogged doesn't matter because it takes effect when you write to the wall. So it's half a millisecond for read and 2 milliseconds for write. That's okay for a cache, right? Yeah, that's okay. Actually, I would stay even with the logged because I think the write to cache is not less critical in our case. And this is the result from Redis. Here it's P50. We are not comparing apples to apples. What was the P50 there? I don't know. So here it was about a tenth, a scale of tenth. So 0.09. Yeah, that's a cache. That's a good cache. And write 0.1 milliseconds. So overall, we see that Redis was 10 times faster. In general, it tried to make more improvements and it didn't really help. So it's still that Redis was about at the scale of 0.01 millisecond, and Postgres was about 0.5 millisecond for read, right? And for write, it was about 2 to 5 milliseconds. So let's ignore for a minute the write. The reads are what important usually for cache. So we see here a scale of 10. If 0.5 millisecond is good for us with the TPS, I think TPS for Redis was also higher. We can use it as cache, why not? If we really need super low latency, then we must still stick with Redis. We wouldn't be able to replace it. So this was whether we want to replace Redis with Postgres when for cache.